So then now the next problem we have is actually from an AP exam in 2002. And if you look up on Google or whatever and you find question 58, this is exactly the problem that you would find. So let's go through it. It may sound a little complex, but it's really not. So let's go through it. It says we have a reaction with 2 moles of N2H4 gas, and we're adding it to N2O4 gas, and we're going to make a series of nitrogen gas, the 3 moles of it, and we're going to make 4 moles of water. So it says when 8 grams of N2H4, which has a formula mass of 32 grams per mole, and 92 grams of N2O4, which has a formula mass of 92 grams per mole, are mixed together, what is the maximum mass of water that can be produced? So they're basically asking us for the product when the reactants are all the way over here. So now you know it has to be something with moles, because there is no way that we can do it by any other method where you have a reactant and we have the information for the reactants and we have to find out what the product is. So basically we have to do the mole calculations first, and the limiting reagents comes back into our little dilemma. So we have 8 grams per mole, so we're going to do N2H4 first. We're going to have 8 grams, and we're going to divide it by the formula mass that they gave us, which is 32 grams per mole, and we get a quarter of a mole. Simple. Now we have N2O4, and we have 92 grams of it, and its formula mass is 92 grams per mole. So we automatically know that that's going to give you 1 mole of N2O4. Now, we have to figure out, again, which one is limiting, because the limiting reactant determines everything. The limiting reactant determines the mole relationship between the limiting reagent or reactant and every single element or compound in the reaction. So let's go through it. We're going to say that there's 1/4 of a mole here and 1 mole here, but we have to use ratios now, because the model is for every 2 moles of N2H4, I'm getting 1 mole of N2O4. So think about it simple. I need to put in 2 moles or 2 moles of N2H4 to get 1 mole of N2O4. So we have to try to get this one equal to this one by using molar relationships or ratios. So I'm going to multiply the one that is less, which is 1/4 of a mole, and I want its relationship to N2O4. So I'm going to put whatever number that I have for N2O4 on the bottom so I can cancel out. So we have 1 mole of N2O4. N2O4. And I'm looking for the new moles of N2H4. So I'm going to always put that on the top. Whatever I'm looking for in ratios, you always put it on the top. So it may sound confusing with all these different numbers, but just remember, whatever you're looking for goes on the top. So I have 2 to 1. So for every 2, I'm putting 1 in. So I'm going to try to satisfy and make this bigger to try to be in comparison with this, given the relationships or the ratios that we have. So it's for 2, every 2 to 1. So 2, what I'm looking for, to 1. Now I'm going to do a simple multiplication. And with this, we get a 1/2 a mole of N2H4. Now, even when we use the molar relationships, it still turns out that N2H4 is limiting. So this is the guy that's going to determine everything in the reaction. So we're not even worried about this character right here. So we have to find out water. Now it's established that for every 2 moles of N2H4, we're going to get 4 moles of H2O. So that's basically, we're going to do a simple calculation. So we found out the moles of N2H4 before, and we got 1/4 of a mole. Now we're going to do the mole relationship. We have, let me get back to the problem. We have 2 for every 4. So 2 to 4, that's the same thing as saying 1 to 2. So we're going to try to multiply it by whatever we want on the top, 2, and we're going to find the moles of water. So we have 2 to 1 mole. 4 to 2, same thing as 2 to 1. And when we do this, we're going to get, because remember, this is the limiting reactant and it determines every single compound, right? So we're basically solving for the moles of water, but we're using the moles and we're using the limiting reactant as a model because it says what is the maximum mass that can be produced. So we have to bank it on the one that is slowing everything down. So when we do that, we get half a mole of H2O. Now, this is what I love about moles because moles explains the relationship. So whatever's slowing it down, everything else is based off of that. So we don't care that they gave us 4 moles of water because that's not the true mole. The true mole is depending on N2H4. So we have half a mole of water. So all we got to do, remember, moles times formula mass equals grams. They said what is the maximum mass, so we're assuming it's in grams. And we're going to say half a mole of water, so we're doing this for water, times the formula mass of water, which is 18 grams. And we get, 18 grams per mole, and we have half a mole. The moles cancel out, top and bottom, and we get 9 grams of water that we have. So that was simple. I mean, it required a lot of steps, but we still got through it. Just remember, the slowest reactant determines everything else. So we always have to find what's limiting because you can often get confused. And also remember your ratio. Whatever we're looking for goes on the top automatically. The 2 that we had here, we were looking for the moles of N2H4, so that always goes on the top. Same thing here. We're looking for the moles of water. So the water's, which was 4, but we divided it into the simplest ratio, and we got 2 to 1. So that was pretty simple.